Hello and welcome to eCraft. In the previous video, we introduced the Microbit V2 from BBC and explained its features. We also demonstrated how to get started with programming the Microbit V2 board quickly using the Arduino IDE as the development tool. In this video, we will explore how to access the I/O pins of a Microbit V2 board in an Arduino sketch. As Microbit was not originally supported on Arduino IDE, accessing the I/O pins can be confusing and frustrating for beginners. While information on the external I/O pins is available, finding information on Microbit to Arduino pin mapping for the internal I/Os can be challenging. Since the Microbit board comes with several onboard I/O devices, it is important to know the pin numbers of the internal I/O pins connected to these devices or sensors. Let's begin by discussing the onboard 5x5 LED matrix of Microbit. If you refer to the schematic diagram of Microbit V2, you'll see that each LED in the matrix can be controlled by two signals. If the column signal for an LED is driven low and the corresponding row signal is driven high, the LED will turn on. To determine which I/O port pin to use for the row and column signals, we can look at the edge connector of Microbit V2. There are 5 connections available, each corresponding to one of the 5 LED column signals. These signals are labeled as P4, P7, P3, P6, and P10 in sequence. In an Arduino sketch, the LED column signals can be accessed using their respective pins, 4, 7, 3, 6, and 10. How can I obtain the port pin numbers for the LED row signals as they are not specified in the edge connector pinout? This has been a bit of a challenge. However, after some research and trial and error, I have managed to find the required information. I am documenting it here in order to assist others who might need this information. The anode pins of the LEDs can be accessed in an Arduino sketch using pin numbers 21, 22, 23, 24, and 25 for the row signals. Now that you have the pin numbers for the LED anode and cathode signals, working with the board will be as simple as any other board supported by the Arduino IDE. To turn an LED on, you need to set the pin mode of the corresponding row and column signal to output. Then, you can use the digital write function to drive these signals to high or low. For turning on an LED, the column signal should be driven to low, while the row signal should be driven high. Let's check whether we can use the pins to access the LEDs. The pins for the LED row and column signals are defined in the code as we previously discussed. The remaining part of the code is straightforward and sequentially turns each LED on for 200 milliseconds and off for 200 milliseconds. Let's briefly go through the sketch and then download it onto a Microbit V2 board. Let's move on to the next topic. The device has 2 buttons labeled A and B located on each side of the built-in LED matrix. These buttons serve as input for the microcontroller. The port pins for these buttons can also be found on the edge connector, specifically on P5 and P11. Therefore, in an Arduino sketch, the pin numbers for these buttons will be 5 and 11. The Microbit V2 board has 4 touch-sensitive inputs, in addition to 2 buttons. There are 3 touch sensor pads located on the edge connector of the Microbit V2, with pins 0, 1, and 2. Additionally, the golden Microbit logo is also a touch sensor contact that can be accessed using pin 26. It is crucial to understand that the touch sensors located on the edge connector pins P0, P1, and P2 operate in resistive mode, whereas the touch mode of the logo is capacitive by default. Additionally, it is essential to note that the touch inputs are active low, meaning that when the contacts detect touch, the detected signal is low. Great! Let's now move on to writing a small sketch that will test all the touch inputs. This sketch is designed to recognize when an input is touched and display the corresponding value on the built-in LED matrix. For example, if the logo pin is touched, it will display the Microbit logo on the display. The previous video on this channel demonstrated the use of the Adafruit Microbit library. This library simplifies the process of displaying graphics and numbers on the 5x5 LED matrix display. The sketch is short and simple. Let's upload the sketch and test it. Remember to keep your feet on the ground for the touch sensor to function correctly. Great! It seems to be working well, doesn't it? Today, we have covered the I/O pin mapping for the LED matrix, 2 push-button inputs, and touch sensor inputs between Microbit and Arduino. In the next video, we will explore the remaining I/O pins. Thank you for watching, and please consider subscribing to encourage us to create more videos like this.
I'm